look, here what do we have to write down? The vertical asymptote. Where do we have to check when we are dealing with the vertical asymptote?
Under
Yes.
yeah.
Yes, that's where we have to check when we are dealing with the vertical asymptote. We have to check right here. So what is that vertical asymptote? X is equal to -2. That's the equation of the asymptote. I just wrote it quick here, but it was supposed to be the equation of the asymptote, right? Then the equation of the vertical asymptote. Now the equation of the horizontal asymptote is it's y is equal to 1. If you write 1.
I say I'm not yes like wrote y is equals to, but then each of them. I say now, bro.
I see. Then the domain. How would we write the domain?
Domain.
Yes. Would write.
X is an element of a real number.
Okay, x is an element of real number, but our x
is not
equal to
-2.
Not equal to the what? To the asymptote, right? Yes, because as an asymptote, what is an asymptote by definition? Do you remember asymptote?
It is that line.
Which one? What does it do? What does it do?
It indicates that the line that you plotted in is not going to be past asymptotes.
It's not going. It's going to get as close as it can, right?
Yes,
but cannot
going to
touch. Cannot touch. Yes, but it's going to get as close as it can, right? Yes. Then the range. Okay, maybe to just elaborate on that definition, because it's very important. If this one is an asymptote, the line is supposed to go as close as it can, but it should never touch that line. Yes, if this is the horizontal asymptote, it means that the graph can go as close as it can. Don't compare to your graph. I'm just talking about asymptote.
Yeah, the Sporos one is very big.
Okay, you sit properly first. Yes, sit up. Okay, fine. Now, so we are saying we have this dotted line, and having this dotted line, we are saying, let's say this line is a what? Is a horizontal asymptote. Precisely for what to say, horizontal asymptote. We're saying, and let's say this is a graph. Then this graph is supposed to get as close as it can to the asymptote, but should never what? Should never touch the asymptote. All right, let's now write the range. The range will be what? Y element of real numbers, but our y is not equal to 1, right? Yes.
And the but then the level is not equals to.
Yeah, that means that you haven't really done what we were supposed to do, right? Yes, because we are supposed to measure this. Remember what I was saying? Is
meaning that
on this part, only on this part.
Oh,
yes. I know on the drawing it will be fine.
It will be fine.
But only on that part it will be right. Okay, so look, we said on the domain, if you write this part correct, I'm emphasizing this. On the domain, if you write this part correct and you leave this part, then you have forgotten something important. Okay? If you also write this part correct, but this part is not there, then it becomes what? Wrong. You remember? Yes. So let's make sure that we write both this and that. This and that. That's how our domain can become correct and our range can become what? Correct. We are taking everything from the asymptote like that. Let's talk about the coordinates of the intercepts. How do we get the coordinates of the intercepts? What do we do? Oh, let's start with the x-intercept.
Y is equals to 0.
Yes. We said the first thing you have to write is y is equal to 0. There is a mark for just writing that y is equal to 0. Very easy. If you skip that, you may not have that mark, right? So write that mark like y is equal to 0. Write that point, that statement, that y is equal to 0. And then from here, you are going to have our y. Okay, our graph, this graph of g of x, I just changed it a little to be g of x, can be written as y, right? Remember, all g of x, f of x, p of x, q of x, h of x can be written in form of what? Y. They can be written as y, all those things. Yes. So we have minus 2 over x plus 1 plus 1. So where are we putting 0?
Plus 2, sir.
Oh, plus 2. Oh,
Plus 2p.
Okay.
Yeah, fuck. Oh,
Yeah. So from here, where are we putting 0? On y. So 0 is equal to minus 2 over x plus 2 plus 1. Then from here now, guys, you need to know you are transposing. And when you are transposing, make sure that you really do the transposing. Check the sign. You are not rushing for anything. Check the sign. It's positive. It's going to go there. It's going to be what? A negative 1 is equals to minus 2 over x plus 2. Okay, before we do cross multiplication and everything, what did we say we have to do? Number 1 here, over what? Over 1. And here, put what? Brackets.
we can cancel here, sir.
Those ones cannot cancel. 2 and 2 cannot.
Negative 2 and positive 2.
Yeah.
Class divided.
Okay.
Cancel. Ema. Bendera tunasema hapa na hapa.
Okay. No. It's fine. Let's see it this one. Let's see it this way. Okay, the best way to find out is just to say, let's say you are given 2 over, let's say 6 plus 2. Do you divide 2 here?
No, sir.
You don't, right?
Yes.
So you don't do that. Alright, guys. No. Fine. All right.
Makasusela antu wapi?
So look at this. We're supposed to multiply this part, right?
Yes.
Diagonal, cross multiply, and cross multiply the other diagonal. So we're going to have what? Negative 1 multiplied by x plus 2 is equal to negative 2 multiplied by 1. So here we get what? Minus x minus 2 is equal to negative 2. Then we take this to the other side, we get minus x is equal to negative 2 plus 2. Yes. So minus x actually is equal to 0. Divide both sides by negative 1. Divide both sides by negative 1.
X is equal to 0.
Yeah, x is equal to 0. All right. So if we are writing this as a coordinate, it means that okay. So here we are saying x is equal to what? Is equal to 0, right?
Yes.
So x is equal to 0 will mean that wherever there is x, you are putting what? Minus 2 over 0 plus 2 plus 1. So you can talk now,
I say the correct answer is 0.
Okay, it's 0, right? Yes. Y is equal to 0. So this coordinate says what? 0, 0. Right. Yes, that's correct. Let's go for plotting because now we are done, right? We are done with what we want. When you are told to plot, you need the asymptotes, you need the x-intercept and the y-intercept. Asymptotes, x-intercept, y-intercept. So let's do that. What do we need to do? We need to plot here. Okay, let me just do this and
Sir,
this. Yes.
you play for an extra point.
Our extra point, we are going to talk about those things. When we get there, don't worry. Yes, we'll talk about it. But for now, let's just deal with the, when we are sketching a hyperbola, you just know that we need a vertical and horizontal asymptote, which means we need asymptotes, and we need x-intercepts, and we need what? Y-intercept. I'm going to dismiss you very soon now.
What have I done, sir?
Bayashiyeka sewu-add
That's not good.
I'm sorry, sir.
All right. So
I'll never do that again.
now we come to this one. Look, what are our asymptotes? Our asymptotes are at -2, right? Okay. Where is -2? To the right or to the left of the origin?
left.
To the left, right? So the vertical asymptote, I'm supposed to draw a line that goes like this. Right here. And here is what? -2. Let me label it here. -2. All right. Then from here, we also need the horizontal asymptote. Where is the horizontal asymptote? It's at what? At 1. Where do we see 1? Down or up?
Up.
Up, right?
Yes, sir.
We are all seeing that it's up. So we come right here, up. We come and draw an asymptote that's going to pass at 1. So this is our 1. So we write our 1 here, it's +1. Now, let's plot our coordinates. Let's start by plotting this one, right? Yes, let's plot it. Where is it? It's right here. And let me use a different shading. Okay. It's right here. On the origin, 0, 0, right?
Yes, sir.
The other one is at the same point, right?
Yes.
Yes. So we don't have to worry much about plotting anything. Now, what do you need to do? You need to know that when you are plotting a graph, you start from close to the asymptote. Yes, that's correct, Anil. We start from the asymptote, then we cross at that point, and we go to the other what? Asymptote. But for this graph to be complete, never leave the other side, because they walk as two, these ones, right? They are in pairs. We only drew one part. Where should we draw the other one? Here?
There.
Where is the
Ba. Fondan u0.
pencil? Here?
Ulapho 0 manier.
0?
Yes.
Yeah, we drew here, this 0 is fine.
Azizoba up.
It's going to be in the other diagonal.
Kube kutheni
Hey, listen very carefully. We are saying, if you draw this side, you need to draw the other one in the other what? In the other diagonal. We take this from the other side, we go close to the asymptote, to the center of the asymptotes, or where they are meeting, and then we go to the other side. So that's it. Often, people, when we construct one side, we end up drawing only one side. But you need to remember that the hyperbolic function 2, 2, this diagonal and that one, or if I draw this one and this one. You understand this, right?
Yes, sir.
Yes. So that's how we actually how we actually sketch this one. Let's try this one. F of x is equal to you want 8. Not a problem. So yes, you are using the same questions. Okay, let's take them from here. You are taking did you copy the questions? Or did you copy this one? Yes, copy this one, and then you use the same questions, the ones that we had here. Write down the vertical asymptote, the horizontal asymptote, domain, range, then calculate the coordinates of the intercept, and then sketch the graph.